Okay, so here's my version. Again, you might have different numbers. Okay, so I have 4 over x squared plus 2. Okay, and so the first thing it asks is for the first and second derivative. So let's quickly give it, let's go ahead and grab the first and second derivative. So the first and second derivative here, since you're asking about the parts with the graph, I'm just going to go ahead and skip ahead to having the derivatives. So if you want to calculate these and you're watching this later, you can ask me to calculate them. But f prime here works out to be minus 8x over x squared plus 2 squared. And f double prime is 24x squared minus 16 divided by x squared plus 2 cubed. Okay. So that's our derivatives. And then what the question asks is it gives us these things and says, which of these is the graph of f in blue and f double prime in red? So we have things like, and I will attempt to reproduce these very roughly here. My A looks like, and I guess I can use blue and red because I have blue and red. My A looks something like this. Very, very roughly again. My B, so this is A, this is B. So here we have something like I guess the point is the graph is always the same because they've shown you what the graph of f looks like. It looks roughly like this. They're just asking, hey, of those, which of these must be the graph of the second derivative? Okay, and I'm just going to get these close enough that we can read it off. It will not be perfect. We will make do with the fact that it won't be perfect. So then my graph of C looks something like this. Let's go ahead and put the axes down for this. Like that. Something like that. And this now looks like that, and this looks like this. Okay, so before we look at which of these options looks right, let's just look at the graph of f itself. So the graph of f itself, again, looks something like this. Again, very roughly. And I want to think about the concavity of this graph. And so if I look over here, say, this is concave up over in this piece. So it's concave up over here. Then in the middle here, it's concave down. Okay, and then over on the far left, it's concave up again. And if I try and very roughly feel out the inflection points, that is the points where it changes from concave up to concave down or concave down to concave up, it looks something like these, right? These are approximately my inflection points. Okay, so let's think now what this all means in terms of the second derivative. Okay, so we're going to sort of break this into pieces. Okay, so we know that the second derivative should be positive where the function's concave up, and negative where the function's concave down, and it should be 0 at the inflection points where it changes. Okay. So here, f double prime should be positive because the function's concave up. And so the red graph, that's the second derivative. It was a coincidence, but I picked the right color. The red graph should be positive over in this zone. The second derivative should be negative here because the function's concave down, so the second derivative should be negative. And the second derivative should be concave, or sorry, the second derivative should be positive over here because the derivative, sorry, the second derivative should be positive because the graph is concave up. And likewise, at exactly these spots, the inflection points, the second derivative should be exactly 0. Okay, so if I look at the 4 options, well, I need the second derivative, the graph in red, it needs to cross the axis at these 2 spots because it needs to be 0 at the inflection points. Neither of these does anything like that. In fact, this one, the red graph is always negative, so the function, if this were the second derivative, would be concave down everywhere. Likewise, this one changes, but it changes at that point. This is actually the derivative, not the second derivative, if you want. So that leaves only these 2 as possibilities. And so we have to look and see, okay, which of these 2 red graphs actually matches the properties that I said I'm supposed to have. And the 2 that actually match are, well, what's the difference between these? One of these is negative and the other is positive in each spot. So which one is positive where it's supposed to be positive and negative where it's supposed to be negative? It's this one. It's A. B is upside down. Okay. So of these, the only one that agrees with everything we said here is graph A. Okay, so question C asks you, okay, is the graphs of f and f double prime indicate what is in the form of an interval? Okay, so now it wants you to, for whatever reason, look at the graph and decide where the function's concave up. And so, for example, mine is concave up. Mine is concave up on this piece. Sorry, mine is concave up on this piece and concave down on this piece. And when it's saying use the graph, what it's encouraging you to do is to actually read off of the graph where the second derivative is positive and negative to answer the question. Which is just a different way of doing it than what we did earlier, because earlier we just solved it. And so you could do the same thing. You could figure out, okay, where is 24x squared minus 16 over x squared plus 2 cubed? Where is that positive and where is that negative? If you wanted. But I agree, they're not on the exact point, so I think it wants you to approximate, and I assume it is fairly forgiving. But if it's not being forgiving, what you can do is you can just go back and solve when this is 0. Because again, I'm looking for places where the second derivative is 0 to figure out the inflection points. And so in this case, if I wanted to do it, I would go back and say, okay, where is 24x squared minus 16 equal to 0? That's at x squared equals 16 24ths, which there's an 8 in both of these, so that's 2/3. So that's x equals plus or minus root 2 over 3. And so you're, of course, completely right. There is no way that you could read, oh, it's exactly plus or minus square root of 2 over 3 off the graph. But if you want that, these are the points. And so since we know from the graph that it's concave up on the sides and concave down in the middle, then we actually have, okay, so it's concave down from minus root 2 over 3 to plus root 2 over 3, and then it's concave up on minus infinity to minus root 2 over 3, and on root 2 over 3 to infinity. And so it's not that the graph is completely useless. It at least spares us that part before where we had to like draw out the number line and find test points and all that sort of stuff. We know what shape it is, and we just needed to find the points algebraically.